Here's number 8. Jamal rides his bike at 10 meters per second at the top of a 15-meter hill. Assuming that Jamal and his bike are isolated from the environment, determine Jamal's speed at the bottom of the hill. So I had to Google stick figure kid on bike because I tried to draw it. It did not go well. Okay, so here is sort of an idea of what this situation looks like. Oops. And that's him at the top of a 15-meter hill going 10 meters per second, and then him at the bottom of the hill going who knows how many meters per second. So first things first, let's label the types of energy. We've got GPE and KE at the top, and we've got KE at the bottom. So that means that all his GPE that he has at the top gets converted to kinetic energy at the bottom, which means he should be going faster at the bottom than he is at the top. All right, so let's calculate some stuff. Let's calculate his GPE at the top. You know what? There we go. So let's do GPE1 equals MGH1, which is his mass is, we don't know his mass, so we don't need to know. We know it's M times 10 times H1. H1 is 15. So it's going to be 150 times whatever his mass is. And I'll put that in there. This is GPE. I know his GPE at the bottom is 0, so I'll just put that there. All right, his kinetic energy. His kinetic energy is 1/2 mv squared. Oops. Which is 1/2 times m, which we don't know, times 10 squared. 10 squared is 100. 100 divided by 2 is 50. So his kinetic energy is 50 m, which puts his E total at 200 m. Which means that goes down there, which means his kinetic energy at the bottom has to be 200 m. So let's calculate that. Let's calculate his speed, I mean. So KE2 equals 1/2 mv2 squared. That means 200 m equals 1/2 mv2 squared. First things first, I'll get rid of m, and I'll multiply by 2. I'm going to move my work over here. So I get 400 equals v2 squared. I take the square root. I get that v2 is 20 meters per second. And that makes sense. I did say that he's going to be going faster at the bottom than he was at the top. So there you go. That's how you do that one.